Hello viewers, welcome to my channel. So today we'll be discussing about traveling salesman algorithm and its approaches. So there are three approaches we'll be discussing individually. One is brute force approach, second is branch and bound approach, and third one is approximation approach. So brute force, branch and bound, and approximation. So in this video, we'll be discussing the brute force approach, and individually we'll be discussing other approaches in the next videos. So coming to the objective of traveling salesman problem. So the objective is that to find the shortest possible tour that visits each city exactly once and returns to the starting city. So in the sense you have to start at a particular city. So traveling salesman objective or the goal is to identify the optimal solution. The optimal solution is nothing but to identify the shortest path or the shortest distance or the shortest tour. So how you will be identifying this shortest tour? You have to start at a city, one city, and you have to visit every city exactly once, only once. So you cannot repeat again and again. You have to visit each and every city exactly once and return to the same city where you have started. So you have to start at one city, visit each city exactly once, and then return to the same city again. So in between how many number of permutations of the distances or the tours generated, you have to calculate the distance for each possible tour and then identify the minimum distance. That is nothing but the shortest possible tour. So now we'll be looking into the first approach, that is brute force approach. So in this video we'll be looking into the brute force approach. Let us move on to the algorithm first and then we shall discuss with the example. So coming to brute force approach algorithm. So here the first point is that modeling the problem, which means that your TSP, that is traveling salesman problem, can be represented as a weighted graph. Weighted graph is nothing but for each edge a cost will be given. Based on that cost you have to calculate the distance. So TSP can be represented as weighted graph where each vertex represents the cities. So here each vertex will be represented as the city. So each vertex is nothing but a city, and next edges are nothing but represents the distance. So first one is that TSP can be represented as a weighted graph. So your problem will be represented as a weighted graph, where in that weighted graph each vertex is represented as a city. So the city is nothing but the vertex and the edges are nothing but the distance between the cities. So here each edge will be accumulated or allotted with a cost. So that cost is nothing but the weighted graph. And next moving on to the second step. So this is generating tours. So once the graph is given to you with the cost and everything, so then you have to generate tours. You have to generate all permutations of the intermediate cities excluding the starting one. So you are starting at a particular city and you are visiting each and every city once. So those tours has to be calculated, which are nothing but the permutations. So intermediate cities, excluding your initial city, you have to start traveling across each and every other city that is present, and then you have to identify the distance, calculate the path, and then return to the same city where you have started. So that is what generating tours is. Generating tour in the sense permutation of all possible distances between the intermediary cities from the initial city you have started. Next, moving on to computing tour length. So once you start traveling across each and every intermediary city, you have to calculate the length of the distance. So from the starting city to that intermediate city, whatever you have traveled, you have to calculate the tour by summing up the distances between those cities. So that is what third step is. So first one is modeling the problem, where a graph will be given to you, which is a weighted graph, where each vertex will be represented as a city and each edge will be represented as a distance between that particular cities that are represented in the graph. Next, second is generating tours. You have to generate all possible tours starting from the starting city to all the intermediate cities that are present. And next, you have to compute the tour length. So you have to calculate the length of each tour. That is, in the sense, suppose you have started at a particular city A, you have traveled across B, then you have to calculate the distance between A to B. So, and then you have traveled to city C, then you have to calculate the distance between A and C. So that is what the third step is, computing tour length. In the sense, calculate total length of the tour by summing up distances between consecutive cities. So it is nothing but summing up distances. So you have to sum up the distances between consecutive cities. So these are the first three steps. Next, moving on to the fourth step. Fourth step is nothing but compare lengths of all generated tours and select the tour with the shortest length. So once you have visited each and every intermediary city and calculated the length of the tour for each every city that you have visited, so you have to finally identify the shortest length that is present. So that is what finding the shortest tour is. So total in traveling salesman problem, you have total of 4 steps. One is modeling the problem. The second is generating the tours. Next, third is computing tour length. Next, fourth is finding the shortest tour.